In this video, we're looking at square roots. Square roots are real numbers. We talk about exponents a lot. And so exponents, multiplying in a lot of different ways, right? So multiplying 1 times 1 times 1 times 1, or 5 times 5 times 5 times 5. So exponents give us a way to kind of, in a shorthand, in a shorter way, represent multiplication, same number over and over and over again. And we're looking at the same idea here, but maybe in the opposite way. Square roots. So square roots are real numbers. First, I'm going to write these down. We're going to write the list of the first 20 perfect squares. And a perfect square is basically the square root of a real number, a whole number. So 1 square is going to be 1. 2 squared is going to be 4. 3 squared is going to be 9. 4. So pause it, write these first 10 down. You probably know or maybe remember looking at these maps. I'm assuming you have these all written down. Now we can move on to the next couple. Right, so 7 squared, 8 squared, 9 squared, 10 squared, 11 squared. So you are probably shouting it out right now, you know what it is. And 11 squared is going to be 121. So 121. 11 squared. 12 squared, 12 times 12 is 144. 13 squared is 169. And 14 squared is 196. 13 and 14, now you'll have this list as notes. You don't have to memorize all these. But the more you can have in your mental tool bank, the more things you can have stored in your memory, the faster you'll be at different problems. And it'll just be just a slightly bit easier. But you do have your notes. But 13 and 14 are very similar. 13 squared and 14 squared, it's just the reverse. So if you can't write the reverse, but we're just flip-flopping the 6 and the 9. So 13 squared and 14 squared, if you can remember 13 squared, and I don't know why, but for whatever reason, everybody seems to remember 169 in 7th grade. Everybody seems to remember that one. So 13 squared is 169, and then 14 squared, 196. If you can remember that, I giggle like weird in that way because it makes it easier to remember. It's creepy. So 169 is 15 squared, 114, or 196, 14 squared. 15 squared. Since 5 times 5 is 25, 15 times 15, 225. That's just the way I remember it. That's not why it's 5, but I remember 15 squared is 225, because 5 times 5 is 25, and it's going to be bigger than 14 squared, so 225. 16 squared, now 16 and 17, they count. I'll show you what I mean. So it goes 5, 6, 7, 8, 9. 16 squared is 256, 17 squared is 289, and the way I remember that is it counts 5, 6, 7, 8, 9. You don't have to memorize it, but that's the way I remember what 16 squared and 17 squared work out to be, because it counts in that way. Again, not necessary for you to memorize, you will have your notes in front of you. That's how I did it. 18 squared. I know that 18 squared is getting pretty big. We're probably going to be out of the 200s now, and so it's going to be in the 300s. 8 times 3 is 24, so 18 squared is 324. 8 times 3 is 4. So 18 squared, 324. That's how I remember. I don't have a nice way of remembering 19 squared. All of the numbers are multiples of 3 for this. It ends up being 361. 19 squared. 3169. I guess that's, I don't know. 20 squared then. The tens place. 10 squared, 20 squared, 30 squared, 40 squared, 50 squared. All those multiples of 10 are pretty easy to remember. Since 1 squared is 1, 10 squared is 100. 2 squared is 4, 20 squared is 400. 3 squared is 9, 30 squared, 900. So 4 squared is 1600. It goes from there. So multiples of 10s are not too bad. Have those written down, if you don't already. Make sure you have those easily accessible. Because it's going to make the rest of these problems much, much faster. All right, a number that is multiplied by itself to form a product. It's called square root of that product. And I'll show you an example of what that means. So, the big example, I'm going to unveil something here. I want you to pause it, write it all down, and we'll go through it. Pause it, write this all down. All right, so 4 squared. 4 squared is 16. 4 times 4 is 16. That means, hence, hence, it's not all smart when you say that. Since 4 squared equals 16, hence the square root of 16 equals 4. So it works like this, 4 squared equals 16, and it works like this, square root of 16 equals 4. It's just the inverse, it's the opposite. It's saying that since 4 times 4 equals 16, the square root of 16 is 4. The problem comes up when you look at the next one. Negative 4 times negative 4 is also 16. Negative 4 times negative 4 is 16. Therefore, I'm just having fun with words today. Therefore, the square root of 16 also equals negative 4. If that doesn't make you stop and go, it should. The square root of 16 has two different answers. The square root of 16 equals 4. The square root of 16 also equals negative 4. It equals two different numbers at the exact same time. Square roots have that inherent ability that since 4 times 4 is 16, the square root of 16 is 4. Since negative 4 times negative 4 is 16, the square root of 16 is also negative 4. In fact, all square roots, or except maybe 0, but square roots are going to have two different answers all the time. And this is going to be a huge part of next year's material, the second half of that algebra book. We have two different results. Now, as mathematicians, we're lazy. It's just well known that mathematicians are lazy. And so we have a way of writing this. Rather than saying the square root of 16 equals 4, the square root of 16 equals negative 4. Rather than writing two answers every single time, because that's a lot of work, we have a faster way of writing that. And that's what's right here. Positive numbers have two square roots. The square root of 16 equals plus or minus 4. So write that down. Pause it, write that down. But the square root of 16 equals plus or minus 4. So that plus minus sign is a shorthand way of writing both answers at once. Plus or minus 4. We'll see how that's used. So, top 3. Square root of 81. I'll look back at my list here. 81 is right here. Since 9 times 9 is 81, square root of 81 is 9. Don't forget that all positive square roots have two answers, positive 9 and negative 9. Negative 9 times negative 9 is 81, positive 9 times positive 9 is 81. So the answer, plus or minus 9. Square root of 324. Now look back at my table here. 18 squared. 18 squared equals 324, which means the square root of 324 is 18 or negative 18, plus or minus 18. Square root of 121, 11 times 11 is 121, plus or minus. Two answers. This one with 2 points on a test. Ooh, no, we got 3 at the bottom. We got negatives going on, and we got fractions going on. That freaks people out. Let's see what happens though. Remember, some number times itself would have to equal 25/49. So some number times itself equals 25, numerator here, and some number times itself equals 49. I know that 5 times 5 is 25. And I know that 7 times 7 is 49. That means that the square root of 25/49 would have to be 5 sevenths. So 5 sevenths times 5 sevenths equals 25/49. The square root of 25/49 has to be 5 sevenths. Basically, we're taking the square root of 25 and the square root of 49. We're saying it's 5 sevenths. So fractions, don't fret about fractions. They're not that bad. Just think square root of the numerator, square root of the denominator, you got your answer. Negative. We've got two different ways that negative can happen. A negative on the outside of the square root, negative on the inside of the square root. If the negative's on the outside, let's see what happens. We have negative. Square root of 9, well, I know that 3 times 3 is 9. Also know that negative 3 times negative 3 is 9. So really, I've got plus or minus 3 there. And that looks weird. Okay, negative sign, parentheses, plus or minus. It's a lot of stuff going on. So let's try and read this. Negative means opposite. Right? It represents kind of the opposite. Opposite of 3 is negative 3. Opposite of 5 is negative 5. So the opposite, I'm going to read this from left to right, the opposite of positive 3, negative 3. The opposite of negative 3, positive 3. So really we end up with the exact same result. If the negative is on the outside, because we have both this plus and minus inside there, it really just takes the opposite of both. It gives us the exact same result. So if the negative is on the outside, nothing really changes. It's just the opposite of the square root of 9, which is still plus or minus 2. Last one here, square root of negative 16. Square root of negative 16. So what we have to figure out is some number times itself equals negative 16. I can't think of it. 4 times 4 is not negative 4 times negative 4 is not negative 16. And it has to be times itself. You cannot do negative 4 times positive 4 because those are not the same number. It has to be times itself. There is no number times itself that equals negative 16. There are no real numbers that work here. And so we're going to put not real. I did mention in an earlier video that there are numbers that aren't real. This is where not real numbers come into play. We're not going to deal with it. We're not going to worry about numbers that aren't real. But there is a number. It's just not real. So there is an answer. You can't say no answer. There is an answer. It's just not real. So in this case, that doesn't work. Not do negative 4 times negative 4. We're just going to say it's not real. So if the negative is inside the square root, not real. If the negative is outside the square root, nothing really changes. The fraction comes away. Okay. Don't need to write this down. Square roots, the perfect squares are nice and not so bad because we've got those all listed. But there are numbers that aren't perfect. And calculators are going to approximate that value, like the square root of 15. It goes on forever here. It's kind of like pi. Pi goes on forever and never stops. So they're called irrational numbers. Without a calculator, we're going to try and estimate. So I would like you to write this down. Square root of 10. Square root of 10, we don't know what the square root of 10 is. Nobody does. The calculator can estimate it, but nobody really knows what it is. So we're going to estimate. We're going to put some squiggly lines here. That means it doesn't equal. We have no idea what it equals. But we can estimate. The way we're going to do this is we're going to say that some number times itself is 10. Okay. I know that 3 times 3 is 9. That's close. And 4 times 4 is 10, which 4 times 4 is 16. So 10 would be somewhere in between there. And it probably be pretty close to 3. So we're going to say that about 3.1. The square root of 10 is about 3.1. Now that's not perfect because nobody knows what it is perfectly. However, if you put it in a calculator, the square root of 10, we get 3.1622776. It goes on for a while. On a test or a quiz, I will accept an answer that's 2 or less away from the correct answer. Well, I'll give you an example. The best answer possible for this, 3.2. I estimated 3.1. That's pretty darn close to being the best possible answer. On a test or a quiz, you get full points for that. If you said 3.3, I'd accept that. You said 3.4, I'd accept that. You said 3.1, this is the best answer, remember. I'd accept that. So on either side of 3.2, I will accept answers pretty close to it. What I'm going to do is I'm going to try these 3. Look back at your form here. See about where would that number be? Between 3 and 4. 10 is somewhere between 3 and 4. And try and guesstimate. Try and estimate what the square root of 300 square root of 156 to square root of 18. I'm assuming you pause it. I'm assuming you try it on your own. I'm just going to put the answers. If you didn't get the right answer, click on the link or look at the videos below and see if you can fix those mistakes. So square root of 300, the best answer, 17.3, plus minus. Square root of 156, 12.5, plus minus. Square root of 18, 4.2, plus minus. Yeah, if you didn't get those answers, watch the link video, and good luck on the questions after the video.